This is the second video to explain the base case code scenarios for IEEE 33, and it is the same for 69 bus, but is the difference it is the load data and line data, but all the other thing it is the same. So as you see in the current folder here, there is a file. Base case, it is the main program file, and then the line data for IEEE 33, and the load data and the load flow program, and also the profiles for all the parameters. If we first open the line data, as you see here in the line data, we have the number of line here, and this is also the sending end bus and the receiving end bus, and the resistance and reactance of the line. This is consider each row, it is considered one line. This is the second line, third, and so on. Each line contain the sending end, receiving end, the resistance and reactance, the specification of the line. The second file is the load data file. It is defined the buses, all the buses, and the real power load, and the reactive power load, and the ratio. It is the ratio. So as you see here, we have 33 buses, and each 33 has real power and reactive power. This is the specification of IEEE 33 buses. It is the same for 69, but is the different is the number of branches and the number of buses, and the load it is also different, but it is the same structures. The third file, it is the profiling. In this file it is defined the hours, 24 hours, the real load profile, how to deal with the time, and also the third column, it is the reactive power load, how to also profile the for 24 hour. The third one, the fourth one, it is the PV profile, as you see here, how the PV is generated during the time. And in the fourth, fifth, and sixth, it is the distributed generator 1 and distributed generator 2 profile. Then in this column it is the EV profile, and the last one it is the distributed cost, distributed generator cost. This is the profiling that bring from the reference papers, and after that we started with the base case. In base case, it is without any reconfiguration, only the original configuration for the network. It is considered here and make the load flow, and after that get the result from the load flow. As you see here, we clear all the variables and CLC and clear all the command windows, and after that we call the load flow program. That load flow program will get it the output power loss, reactive power loss, voltage deviation, the voltage profile, voltage stability index, the total system cost, and the PLH. It is the power loss during the hour. That mean for 24-hour power loss. And after that we extract the load profile, the load data, line data, and calculated the also the we calculated the load, the total load, the PV, and the distributed generator, and then we calculated here the generation from the grid. And after we extract the output and calculate the parameter, now we printed the result printed power loss, reactive power, voltage deviation, voltage stability index, total cost divided 1000, because the total system cost in the $1,000. And after that we plotted the voltage profile. We plotted also the load PV distributed generation profile, grid profile, system profiles, and after that also we plotted the AV profile, as you see, and the losses profile for 24 hours. This is the base case program. In the explanation, the last video about the base case scenarios, the third video, to explain the load flow, how the load flow deal in base case, and how to extract the output from the load flow code in the next video. Thank you very much.